Good morning. Welcome to our webinar. I'm going to start by introducing myself. Oh, sorry, technical problems here. I'm going to start by introducing myself. Sorry for the echo. Okay, this is the week 1 webinar, the introduction to deep learning, and I have prepared some slides to guide us through. We have an hour of a webinar that will be recorded and displayed on the channel. So the first thing that you have to, I have to be sure that you guys are up to speed this week is with the development tools. So hopefully everybody tried to install Anaconda already, and if you didn't, please bring all your questions to your one-on-one next week so we can make sure that everybody has Anaconda installed. All right. I'm not going to read from this slide, but I'm going to actually show it to you on the screen. So if you just bear with me for a second. I think that as soon as I get this out of the way, essentially this is the slide. I'm going to probably share it in the channel later, but we're going to see NumPy, a couple of vectorized operations, so we're sure that how to do them, and I'm going to show you your first project. We're going to discuss a little bit about that and how do you get organized to do that. And then I'm going to show you a short video of the introduction to deep learning lesson. So it's not replacement for the Udacity lesson, of course, but it's a summary that I prepare, and it takes only 20 minutes. So if you want to go over it and you haven't had time to see the lesson yet, you might find it, like a good summary to get at least understand what is the lesson about, but definitely you have to go over the lessons later on. Okay, so let's see a little bit about the development tools. Of course, I have installed Anaconda already. This is a Ubuntu screen, but I suppose this should look similar in either Mac or Windows. If you go to a console and you type conda environment list, mlist, it's showing me all the environments that I have created. The original one is the base environment, the one that you get by default when you install Anaconda. You can work with that environment, but it's recommended that you create your own. So the other ones are environments that I have created, like for different projects. So if you, for example, want to work in one environment with a particular version of Python, you can create an environment for that and keep your things separated. So if you want to use the environment, I have to activate it. So I will do conda activate, and the name of the environment. For example, I want to use the environment that has TensorFlow. These names are completely arbitrary. I just chose to name it TensorFlow. What it will make it a TensorFlow environment is that if you actually install TensorFlow in that. So these are Conda environments. Conda is essentially your environment management tool, and you preferably install anything in the environment using conda. So you go conda install and then TensorFlow or whatever you want to install. I'm not going to do it here because I already installed it, but just mention it. So once you have the conda environment activated, it's going to show here in the left what environment you are. And if you want to exit the environment, you will go conda deactivate. Conda is not the only environment manager, and there are other tools in Python that allow you to do this, but these are the ones that I'm using, and so that I'm going to explain it in terms of Conda. So once you are in an environment, you can invoke Python and start coding, or you can what we do in this nano degree is using a Jupyter notebook. So you can invoke it like this. This is essentially a client-server application, and the client is your browser, of course. The server runs in the back, so it has taken over this console process, and if you cancel this process, it's going to cancel your server. In Python, they call it a kernel when you have a server running in the background. So when you go here in the Jupyter client in the browser and open some notebook, you will see that it refers to kernel, and you can restart it and change it, everything from this user interface here in the browser. So let's take a look at, let's see if I have something here in Udacity. So, okay. Okay. So here what I am showing is the deep learning master branch downloaded from GitHub from the deep learning nano degree. I think that you can do that at any moment. It should be in your lesson. It should be explained. And there you have a bunch of projects and some labs that you want to take a look at. Here's one about linear regression. I guess this one must be very basic. So let's take a look at the lab. So here you have a Jupyter notebook, and we have a menu here that has one of the menus is kernel. So if you look in kernel, you will see that you can change your kernel. So it offers me to continue working in Python 3. Python 3 is the kernel that I'm using right now, and or I can change to another environment, Python 2.7, or there is another one that is Conda root that you don't know what it is. But in any case, there is a way to change the kernel from inside the notebook, or the alternative way is the way that I show you, which is selecting the environment first. And once you select the environment, you create your notebook inside that environment, that Conda environment, and it is going to work in the environment that you want. In order to be able to change the kernel from inside the notebook, I think that you have to register the kernel in the configuration of the notebook manager that you are using. So that part we are not going to get into today, but you can Google it, and there are some things that you have to do in order to register environments here. It's a handy way also to select environments. Okay. Here I'm showing you a notebook that it probably was mentioned in the lessons, and it essentially asks you to oh, my battery is running low. Hold on, I have to take care of this first. Okay, that's it. So sorry about that. So this is a typical notebook that you will find in a nano degree. It will contain a lot of explanations and boilerplate, and at some point it will ask you to do something. So for example, hey, here, go and load the data in pandas, and it says this none you have to replace it for, maybe, let's see, you are loading the pandas library here and you call it PD, so you go PD read CSV, I guess, and then you have to type here the path of the CSV, whatever that is. But I'm not going to get into that. I don't want you to see me programming here. That would be very slow. But we can actually go and open the solutions. So if you go back to the directory here, because it's a lab, you get the solutions there. This is not cheating. You are supposed to have this information. So so here's the load data expression that he was looking for. So let me just copy this into the regression notebook, and right here, and execute it, and it has loaded this CSV and it's showing the contents. By the way, I'm monitoring the chat. I don't see any comments, so I hope you are aware that you can chat with me during the webinar, and if you have questions or comments, please put them in the chat and we'll address them on time. Okay, some of the helper functions here that is showing in the webinar is not essential to what we're doing, so we can go over them and define them, and here is going to show you the data in a matplotlib plot. So this is called a scatter plot, so it shows you the scatter of the points, and you obviously here have two variables, and all the points are plotted in those two variables. So if you go to the data, you'll see that there is a country, and for each country is a key, and the two variables are life expectancy and BMI. So building a regression model for this data simply means finding a predictor that will try to predict where a point would fall if where the point would fall given one of the variables on the other side. So it's essentially predicting the second variable in base to the first one. So create a regression model and assign weights to weights are essentially the coefficients of the model, and we are going to find the model here with an iterative cycle. So here's the second thing that you have to do, and again I'm going to continue cheating here and just copy the solution from here, but let's go over the solution while we have it here. So linear regression is essentially an iterative process in this case, because we are using an optimization algorithm to minimize a loss. So we go for a number of epochs, and this is a variable that let me just copy this over so you can see it in context. I'm copying the solution into the program. Here you go. So we have defined here that we want 1000 epochs. An epoch is an iteration over all your data set. So how many times are you going to go over these data sets? The learning rate is for each time that you find an error in your approximation, how much of that error are you going to use to correct your coefficients. So I don't know if that makes sense out of context, but once you look at the lesson on linear regression, you'll get a much better idea of what we're doing here. So for each epoch, well, essentially for each time that you read the data and go over the table, for each example. So and x here is not a single variable, but is essentially a matrix that has many rows. So it's saying, okay, let's go over each row, and for each row, let's predict how much is the second variable in base to the first variable. So here's the first variable. I suppose that for the way that is presented here is BMI, and given the BMI, I multiply by m starts in 1, but these two are my output. It's really, I initialize them like that, but in the end I want to find the optimal values for these two variables that approximate this data set. So I multiply I apply basically the linear expression here, multiplying the data, the input data by m, and adding the bias, and that gave me a prediction, which is another scalar that is going to give me, okay, if BMI was 24, maybe someplace around here, and then what I'm doing is comparing the place that I calculated with the actual point. So let's say I got this point. This is the point that I am processing right now in x, and I calculated something up here. So it's going to tell me, oh, you have all this error, and now we have to correct the coefficient that you used to compute up here. So we're going to go, oh, okay, what is the difference between the actual y, so this value, and your prediction, and that difference is going to be used, a little portion of that difference, so we don't go too fast, 1/1000th of the difference. See, the learning rate is 1/1000th. So it's going to be used to correct the coefficient. So every time you have a point, you correct the coefficient a little bit, and the same thing for the bias. Well, after running over all the points here, I completed an epoch, and then I start another epoch, run again and again and again. So once everything is done, I'm going to have m and b, the two variables, corrected. See, it took a little while, a couple of seconds, and now we're going to plot it again and see what have I done. Well, I have created a line with the coefficients m and b. This is the bias, and the incline is the m. The line is the one that has a minimal error with respect to the sum of all the points, the minimal sum of square errors. So this is linear regression, and now we can use this line as a model. So forget about all the blue points. All you got left with is the compression of the information in that data set, which is that line, and you can use that to for a simplified way to predict new life expectancy, in this case based on the BMI. So okay, the prediction is not there yet. So here we go to the solutions and say what is predicting. Well, it's very simple. It's just given your BMI, which is your input variable, that's all you know. You're going to multiply by my m and add the b, and then it's going to give you the life expectancy and there you go. So given this BMI, you have this life expectancy. Okay, I should check my BMI and see how many years I'm going to be. All right. So this is how you go to do a lab. There are a couple of things here that we can discuss. In this exercise, I don't think there is many algebraic operations. All the operations that you see here, they are simple scalars. So xy is a scalar. X is a vector, but xy is a scalar. So all these operations are done in a scalar mode, just to keep it understandable. Once we switch into doing all these operations in vectorized mode, things get a little bit simpler to look, but you really have to keep track of the dimensions of the variables, because once every variable that you are multiplying is an array or a matrix, you really need to know what dimensions are there, because it's very easy to mistake columns with rows. Okay, so once you are done with your notebook, you can go here and say close and hold, and that will close the notebook. I probably going to go back to my original notebook just to leave it as it was, and so before I save it. But okay, so once this this one I didn't modify. So this is how you work with the labs. I just wanted to show you that part. Let me go back to my presentation now and see what was the next one. So that's for development tools. Guys, I don't know if I'm talking to myself here, so if there's anybody online, please use the chat just to let me know. The next thing that I have lined up here to show you is NumPy vectorized operations. So once we want to do things with vectors, I think I have a plan here where, yes. So some of the things that you probably have seen math class on vectorized operations, and it's very clear. And if you haven't, I definitely recommend you to dedicate enough time. It doesn't take long, and it's going to actually clarify a lot of things that you might, have to use later in the nano degree. So we have a couple of operations that are typical here for working with the vectorized operations. Is one of them is NumPy zeros. So the creation of an array, you probably want to initialize it with 0, so the initialization can happen if you do np zeros and just put the shape of the array that you want, and there are some beautiful examples here. So if you just go with a scalar as a shape, it will create a one-dimensional array. But if you say, if you go with a tuple, even if the tuple has only one element, it's going to create a n-dimensional array. You're going to say, oh, okay, so this is really a 5 by 1 array. So here is, for example, a 2 by 1 array. So the 2 by 1 array is, as you can see, it has a double square brackets. So that means that this array has 2 dimensions. The number of nested square brackets is the number of dimensions, and it's simply an array of dimension 2. Is a column of length 2, but is treated differently, slightly different than if you had a one-dimensional array just like that. So here's the creation of a matrix, a simple 2x2 matrix, and you can just keep adding dimensions here and things, but we usually stop here at two dimensions at least in the explanations. But when you are doing vector operations, if you go beyond 2 dimensions, we usually call it a tensor of dimension 3, dimension 4, etc. The math, once you have understood it for 2 dimensions, is the same for more dimensions. So let me just go to my links here. And okay, how are we doing with time? Is over half an hour. So okay, so what I'm going to do is I'm going to put this into the slide, and then when I share the slide, we can go over in more detail, because I have to keep it within an hour, but we can discuss it one-on-one when we do the one-on-ones. So let me just put this in the notes. Okay, so you'll get it when you get the slides. Project. This is important. Your first neural network project is going to be okay. Then this is the slide where this goes. Sorry. Okay. Let me just clean the mess first. Okay, then. First neural network project. What is that? Well, this is what you need to do. This is what you're expected to do to progress in the course. So let me open that. Should have a Udacity at some point here. No? Okay. Well, I'll have to go and click on the link. Where did I? Okay, seems like I have one here. Yes. Okay, excellent. Well, here's the first neural network project, and let's go over what do you have to do. So in this project you build a neural network, and you build it from scratch. So that means that you have to build it in Python. And let me see if we can go quickly over the instructions. So it says, okay, go and clone the Udacity deep learning project, and then once you have done this, you get a directory with all the projects from the deep learning nanodegree. Then you can go into the first neural network directory. So I think I already showed you this, but I'm going to do it again, so we can see this in context. So I have downloaded the deep learning nanodegree project here, and as you see, once you have sync, it says deep learning master. That's a master branch for whatever reason, and in here just look for the first neural network project right there. Click the folder, open it, and you'll find your notebook here. So there is a Python file where you are going to code your answers. So the notebook will import the answers from the Python file, and that's the way that you submit your answers. So it's full of to-do stuff here. So just follow the indications in the to-do, fill out all these knowns, and test it in your notebook. So right now you can open the notebook, and if you go over that, there is a lot of boilerplate code already done for you here, and essentially the reading of the data, and take a good look at the data. That's also always a good idea. So this one are records that go by every day, and you have separated the season, the year, the month, the hour, whether it's a holiday or not, whether it's a weekday or not, or what weekday it is, whether it's a working day or not, and the temperature, weather, etc. Wind speed, okay, and how many people actually show up to rent a bike, how many register, and the total count of bikes rented. So what you might guess already, what we're trying to do here is to predict how many people are going to rent a bike in every particular day, given the weather forecast that you have and the time of the month, whether it's a holiday or not. So we're going to get a prediction over the next month of what is going to be the number of bikes that you have to have in your shop or wherever, so you can meet the demand. Very useful stuff. So here is a plot of, given the date, how many bikes have been rented. As you can see, there is certain pattern to it, there is certain predictability, and you definitely should exploit it if you're running a business to optimize your operations. So here you go into something called dummy variables. Dummy variables are some name that pandas have. Pandas is the data management library. So what it means is if you have a variable that is not an integer or a real number, is actually a categorical variable that it can be, for example, your weekday can be from 1 to 6, or your from 0 to 6, sorry, or your there are many things here, like season 1, 2, 3, 4, or things that are treated as categorical. And here you have it. For example, season, weather forecast, month, hour, weekday, they're all treated as categorical. Sometimes you wonder, why hour is categorical, it's a number. It goes from 1 to 24 or whatever. Well, the reason to treat it as categorical, and this is the essential difference, is no matter, it doesn't matter if the variable is a number or not a number, or is a string, right? The reason that what makes it categorical is that there is no distance. The distance between the categories doesn't exist for your algorithm. I mean, you don't want your algorithm to learn a distance between the two different values of the categorical variable. So if you have, for example, Wednesday, and Thursday is the next day, and it's closer to Wednesday than Saturday, right? So does that mean that your prediction for Wednesday has to be more similar to your prediction for Thursday than your prediction for Saturday? Well, the answer is no. Each day is a day, and you don't have such variable. Maybe there are many examples of this, and so that's why you make it categorical. And I digress here. I'm going to the tangent, but going back to what is dummy variables is a way to call the categorical variables. So that means that you will, instead of having one single column that says season, which 4 possible values, it will create get dummies. It will add 4 columns, one for each value, and each column will contain a 0 or a 1, which means true or false. So that means that in a row you will have season 1, season 2. You cannot see it here, season 3 and 4, but they are there. And so there's going to be a 1 in the season that corresponds to that row, and zeros in the other. So another way to see it is a one-hot encoding, if you have heard that expression. So okay, let's move on. And scaling the variables is something that we always do in regression. Basically, we are going to, well, in linear regression, you are just going to do a weighted average of the variables. So if you see how a weighted average works, basically you are going to be multiplying the value of each variable by a coefficient, adding all that together. So if one of the variables is measured in small numbers and the other one in big numbers, the big numbers is going to dominate, and the small number variable is not going to have any bearing in the results, and maybe it's an important variable. So what you do is each one of the columns is normalized into a 0-1 scale, so that way all of them have the same weight. So well, all right. This goes on, and my objective here is not to explain you how it goes. It's kind of self-explanatory, but to tell you what you have to do. And I think I went over the motions here. You have to fill in my answers code. You have to put your code here. It's going to be called from this notebook. You should start reading the notebook and coming up to the 101s with your first question, and please let's work together on this. And my objective here is in this webinar is just to tell you what to do, what do you have to do. In the 101s, I can hold your hand while you code it, and whether you have to go back to your lessons or what you have to do. So come to your one-on-ones with your questions. So when does it have to be done? Well, I would like you to do it by Sunday 24th. That's 2 weeks from where you started. Actually, the next Tuesday is 2 weeks, but whatever you don't do by Sunday, you probably won't have it by Tuesday. So please try to have it by next Sunday. Let's work towards that anyway. If you don't, that's okay. So I show you how to open the notebook. I didn't show you how to clone the directory, but it's in the page. You just copy paste those things. You have to install Git, and you will immediately get the clone directory. And where to code the answers, I show you this in the myanswers.py. And exactly, you will find you will get to a point where you're not sure what to do, and that is when you can use Slack to post your question, or you can bring it to the one-on-ones, the weekly one-on-ones that you can schedule with me. All right, just getting to the end of this, I'm going to direct you to a short video that I did explaining the introduction to deep learning lesson. So the introduction to deep learning lesson in Udacity is very nice, very clear. You definitely should pay attention and run through it a few times, because it gives you a really good conceptual understanding of why deep learning, and the rest of the learning really builds on those simple concepts. But one thing that happened with deep learning is that you can get very good results without getting too much into the understanding or the math. So if you skip this lesson, you probably will still be able to use deep learning, but the conceptual understanding won't be there, and that will create problems when you have to tweak your models or troubleshoot your models. So so please do the lesson, and if you have 20 minutes, watch my video here. I try to put it all together and in a short time. So let's wrap up here. This is time that I have reserved for QA. When I'm monitoring my screen to see if there is any questions here. Probably give it a few more seconds to make sure that nobody has any questions, and I'm going to wrap it up by now. So guys, that's all for today, and I hope you actually enjoy the webinar, and I hope to see you soon in a one-on-one to discuss the project that we have to do for this week. This is the end of the week 1, and see you next Saturday for week 2. Thank you.